Hello everyone. So today we'll start with session number 17. In previous sessions from 1 to 16 we have seen sketcher, part modeling and features, as well as assembly and types such as standard mates and advanced mates. So today we are going to start with mechanical mates, and in mechanical mates we are going to see gear mate and screw mate. So to start with the parts, we don't need to make parts of gear. So these parts can be called directly from the design library provided by the SolidWorks itself. So at the left side you can see this toolbar known as task pen. So to open the design library, we'll select on the second option here. It is highlighting there as design library. We'll click on the option there, and here we have to go and select toolbox option. In toolbox you need to click on this add in now option. So it will open the library. Library is according to the standards of various countries. So to start with, I'll go for ISO. Either we can go for ISO or we can go for ANSI matrix, ANSI inches, and different type of standards according to country are given here. So I'll go for ISO right now. And in ISO, I'll select the bolt and screws option. And in bolt and screw folder, you can see subfolders are also given there, showing different types of bolts here. So I'll go for simple hexa bolts, structural bolts. Select the folder, and inside the folder you can see two types of bolts are given with the grade option. I will call any one type of the bolt. So you just need to select the bolt and drag the bolt in the screen here. So now I am in a part modeling mode. We can't call the parts of design library in part modeling. So we'll change the interface here. I'll say file, new, and assembly. So in assembly, we can directly use library parts also here. So instead of browsing the parts, I'll go for design library option. From this option, you can go at the back steps. You can see again the standards are showing here. I'll select ISO. In ISO, I'll select bolt and screws, and in bolt and screws, I'll select hexa bolt structural. There are two bolts given here. I'll drag one of the bolt. So now this bolt is been shown here. At left side, you can see the configuration manager, in which you can manage the sizes of the bolt as well as finish, length, thread display, how to display the thread, how to control the length of the thread, and its designation, part name, and everything is given here. So in configure part, you can edit the part as required according to the sizes. First, I'll change the display mode here. And again, I'll go for that part. Now for the size, it is given here M16, M20. So the bolts here are starting with M16 size. I'll go for M16 only. Next, whether this backside of the head required washer face or chamfer face. There are two options been given. In this bolt, it is showing only one option. At the lower side, I'll go for the thread length and shaft length. So in shaft length, I'll select 70 mm here. The thread length, it is showing here as 38. If I say 75, it will take complete threads on the shaft, as the shaft length also was given 75. So even after applying the thread length and length of the shaft, the threads are not being shown here. It is because the thread display we have selected here is simplified. So I'll select that option and go for cosmetic threads. Now you can see an illusion type threads are being shown. Actual threads are not being shown there. So this is cosmetic type thread display. If I go for schematic, then it will show the actual threads there. You don't need to manually make any thread here. In design library parts, bolts and nuts will show by default threads. You just need to select the type of thread display here. If I select simplified, threads will not be displayed. If I go for cosmetic, not an actual thread but an illusion of the threads will be displayed here. And if I go for schematic, the actual threads will be displayed here. So I'll change the thread length here. We are having only two options given here, 38 and 75. I'll select 38 only now. You can later change the thread length also. So before saying OK, again we'll go through the configuration here. You can see the size given here is M16. Finish given here is washer face. Length of the bolt, that is shaft length, it is shown as 75. Thread length, it is shown as 38 mm here. And type of thread I have taken here, schematic. Say it OK. So as soon as you say OK, it will show that part one more time, asking whether you have to repeat this part or not. If you don't want to repeat this part, just go and say close option here. Now one bolt has been displayed here. Suppose if I needed to change the length here or type of washer face or else the thread length or anything, if I want to edit this configuration again, I'll right click on the bolt and say edit toolbox component. Select the option there. So you can see here at the left side, again the configuration items are showing here. If you want to make changes, you can make the changes here, or else we will say OK and come out of the option. So after calling bolt, I'll call the nut here. Same option, design library. I'll go at backside, one step backside. Again, you are having options here, nuts. So in nut folder, there are different type of nuts being showing here. Hexa nut with fine pitch, prevailing torque nuts, and simple hexa structural nuts. I'll call this hexa nut. Now the size for the bolt was taken M16. I'll go for the same size with the nut option also here. I'll select the M16 size. You can see the finish here, it is showing as washer face. If I don't want washer face, I'll say double chamfer. So at both the cross sectional ends, it will have simple chamfer faces. Again, if I change the type here of the finish, you can see washer face. At one side it will show washer and at the other side it will show chamfer. So whatever requirement you have, you can change the option here. I'll go for double chamfer only here. So our bolt was M16 size and nut is also M16 size. Say it OK. I don't want any copy of this part, so I'll say directly close. But you can see the thread display is not been shown here. It is because it was kept simplified only. So I will change the thread display here. Right click on the part, say edit toolbox components. Again in thread display, I'll go for schematic threads. Say it OK. And now we'll go for the concentric mate here between bolt and nut. For that I'll go for mate options. Select the circular face of the bolt and the other circular face of the nut. You can see concentricity has been applied here. Say it OK. So after concentricity, we'll go for limit distance mate here. By double clicking the part, you can see the threaded length, it was given 38 mm. So I want this nut to travel from the backside face till the end of the threads. The distance was 38 mm. So we have seen in advanced mates, we can apply the limit distance mate. Maximum limit will be 38 and minimum will be 0. So the required faces to apply the distance mate here will be back face of the bolt and front face of the nut. So to apply distance mate, we'll go for mates option. Select the advanced mates. In advanced mates, I'll go for limit distance mate. So maximum limit will be 38. That was the threaded length here. And minimum will be 0. Select the required faces to apply the mate. Front face of the nut and the back face of the bolt. Say it OK again. Now as we drag this distance, it is not going at the forward position. We will check whether the mate has been applied or not. So here you can see limit distance mate has been applied, but it is not moving forward in 38 mm. Rather than it is moving at back side. So for changing this dimension of the feed, I'll again edit this feature, that is limit distance mate, edit feature, and say flip dimension here. Say it OK again. After flipping this dimension, this nut is following the distance here. So this was the 0 position. So this is 0 position in which the starting face of the nut and end face of the bolt are coplanar, and it will end at 38 mm. That was the thread length here. So limit distance mate has been applied here. Next we are going to go for screw mate. Select the mate option. Select mechanical mates, and in mechanical mates I'll select the screw mate. So two conditions are being given here. Suppose if I raise this option revolutions per mm, instead of taking value 1, I'll go for 4. So now the rotating speed of the nut will be decreased, as it will take 4 revolutions to cross 1 mm. But if I go for second option, that is distance per revolution, and if I increase this value, I'll say 3 mm. So now in one revolution it will travel 3 mm distance. So both the options are sounding same, but they are different. In revolutions per mm, if you increase the value, the nut speed of rotating will be slow. And suppose if I increase the distance per revolution, the rotating speed or crossing this path will be faster. But before selecting this value, we'll go for the references in between which the screw mate is needed to be applied. For that we have to select the upper circular face of the bolt and any circular edge of the nut, maybe this outer edge, or you can also go for the inner edge here, this edge. Either of these edges can be okay for applying screw mate here. So for nut I'll select this outer edge, And for bolt selection, I have selected the circular face. So these are the selections to apply screw mate here. After selecting the references, we'll go for this distance option. Again, we'll go for distance per revolution as we want to increase the revolution speed. So instead of taking 1 mm distance per revolution, I'll go for 3 mm distance per revolution here. Say it OK. Again OK. And now if I directly drag this nut here, you can see it will not travel the distance here directly. Instead, we have to go for rotation option. So if I rotate this nut by holding any vertex point at the corners, you can see this nut is feeding forward as I am rotating the mouse outside the screen here by holding the vertex point. So in this way, you can apply this screw mate. First, we have applied concentric mate. You can see the mate history here. First, we have applied concentric mate. Then we have gone for limit distance mate to apply the limit distance. So as the nut will travel only the threaded distance here. Then we'll go for screw mate and select the bolt circular face and nut circular edge. So this was screw mate for you. Next mate we are going to see here is gear mate. So after screw mate, the next mate we are going to see here is gear mate. So to call the parts for gear mates or to call the gears, we are having design library here in which we can directly configure the gear and call the required gears here. So we'll go for design library option, select toolbox option here, say add in now, and here you can see the standards given here according to country. So I'll go for ISO. In ISO, I'll go for the folder power transmission, and in power transmission you will get this option gears. So there are different types of gears been given here: helical gear, internal spur gear, rack and pinion spur, straight meter gear. So I'll go for spur gear here. You can see as soon as you drag the part inside, the configuration option will automatically get on here. So now we have to select the module size here. So different types of modules are given for different sizes of gear. I'm going for module 3. This value does not have any unit. It actually represents the teeth size, overall teeth size. Here the number of teeth are showing as 13. I'll say number of teeth I want here is 20. So now the number of teeth showing here is 20. Pressure angle it is showing here 20. The face width is showing 15. Face width it is showing here 15. So this is the face width. Hub style. Now hub style means if you want to provide a hub for the shaft alignment, suppose I go for the second type B, you can see the hub been provided here. So the purpose of this hub is to align the shaft while rotation of the gear. So if I want to change the hub diameter, you can change the diameter here. I'll say it 45 only. Suppose I want this hub on both the sides divided equally. So I'll go for type C hub. So whatever will be the overall length will be divided equally on both sides. The overall length of the hub is showing here as 50 mm. Now this is important term here, nominal shaft diameter. This diameter will decide how much diameter shaft will be inserted here in between the gear. So I want to change this value and say 15 here. So now the nominal shaft diameter is given here as 15. Suppose again if I want to remove this hub that we have taken for shaft alignment, we can go here and say type style A. It will automatically remove the hub here. And suppose if you want keyway for 100% power transmission and for proper locking of gear and shaft, then you can provide the keyway also here. If you want square key at one side, so now the keyway has been provided here. If I want to provide two square keys, then I'll go for the option square key 2. So now two keys can be provided here. Two slots are been given within the nominal shaft diameter. I'll say it OK. I'll cancel the square keys here and then we will say OK here. Now it is asking us if you want to take one more gear same size or if you want to configure the another gear. So I'll cancel this gear I just want one piece here. Now we have provided one spur gear here. I want one more gear with larger diameter and more number of teeth. So again we'll go for design library and call the same spur gear again. But this time in configuration we'll change the sizes. So instead of taking number of teeth 20, I'll go for number of teeth here as 40. So it will double the size of the gear. But the module we should keep the same module. It is very important that the module for both the gears should be same only. Suppose I have taken the module for this gear as 3. So I should take the module for this gear also as 3 only. So I'll change this value and say it 3 here. So now the modules of the gears are similar. Then only these gears will engage with each other. Or else this module is changed, the gear teeth will not engage with each other and they may intersect each other. Say it okay again. If I want to cross check the modules, I'll right click on the gear, say edit toolbox components. I'll say the module here 3. Okay. Again for this, right click the part and say edit toolbox component. And now it is showing the module 3 only here. Say it okay again. Now after taking both the gears here, I'll right click this part. As this part, the first spur gear, it is showing fixed here. You can see the F sign here. So I'll right click this part and say float. I will keep both the gears in floating condition only here. Now I want one plane that is parallel to both the gears front faces here. So we can see here front, top and right. So right plane is coming parallel to the front face of the gears. So I'll select the right plane and say sketch. We are providing two circles here so as to mount the gears by applying mat on that circles so that they can be stable on that circles there, and then we can relatively rotate them each other. So for that I need to show the tooth cut of spur gear 1. I'll expand this model tree here. Here you can see tooth cut option. Just drop down the menu here and say tooth cut sketch show. Now you can see pitch circles are being shown here. We are going to require these pitch circles only. For second gear also I'll do the same process. Expand the model tree, expand the tooth cut option and show the tooth cut here. Again these pitch circles are also being shown here for the second gear. Now I'll make this view normal and select the outer pitch circle and say convert entities. So for the first gear I have made this circle. I'll go for the second gear also. But you can see here as we have converted the entities, it is showing a fully defined sketch. So if I follow the same process for the second gear also, this circle will be converted but it will be fully defined. But I don't want that circle to be fully defined. So for that I am going to manually draw that circle here. I want the orientation of both the gears to be horizontal. That's why I have taken this center point beside this center point only. Now we have to put the diameter. Before that we'll check the diameter of the pitch circle given for the upper gear here. So after clicking this outer pitch circle diameter, the value here it is showing as 120 mm. Same value I will provide for the second circle here, that is 120 mm. And now I want the horizontal orientation, so I'll keep the relation here as horizontal between the two centers of the circles. Next, I'll keep the circles tangent so that the teeth will be properly engaged between two gears. Now we will exit the sketch here. You have to make notice that we have drawn this sketch in assembly zone itself. Next step is to match the gears on the circles. For that we will apply mates here. The mates will be coincide and concentric for each gear with the circle's reference. So we'll start with mates. Select the first circle and the smaller gears front face. Now circle and front face of the gear are coincide with each other. Say it okay. Again the second mate we require is concentric. So we'll select the concentric mate. Go for the selections. I'll select the gear circular face of nominal shaft diameter. And this circle we have drawn. So both the centers of the circular face and the circle will be concentric with each other. Say it okay again. Similar process for the second gear also. First will coincide the face and the circle. Say mate. Select the face and circle. Both of them are coincided. Next we are going to go for concentric mate. Select the selections here. Say concentric and OK. Now as we have made this circles tangent, the teeth we can match here. So now we have matched the teeth here. You can hold the vertex point and drag the teeth as required. We have to properly arrange the gears here. We have to make sure that the gears may not flush each other or intersect each other. After placing the gears, we'll go for the mate option, gear mate here. Select the mate. Now the gear mate comes under the mechanical category. I select the mechanical mates. Go for the gear mate. Now for the reference selections, we'll select the internal circular faces here to apply the gear mate. As soon as you select the internal faces for applying the gear mate as a reference, the ratio option will be highlighted here. So in ratio option, you have to take the ratio as equal to number of teeth. So number of teeth for the first gear were 20. So I'll select the ratio here as 20. And number of teeth for the second gear was 40. So I'll select the teeth ratio here as 40. So this ratio will depend on number of teeth we have taken for the first gear and for the second gear. First value will stand for the first gear number of teeth and second value will stand for the second gear number of teeth. Say it OK. And suppose if you don't take the similar values, this gear may collide each other and will not rotate relatively here. So that's why it is compulsory to take this ratio according to the number of teeth given for the first and second gear. I'll say it OK here. And now when you move or rotate the gears relatively by holding the vertex point, you can see, so even if the gear sizes are different here, the second one is bigger and the first one is smaller, even then the relative motion will be applied here between two gears. We'll hide the sketches first. And you can see the relative motion here. I am rotating the first gear and the second gear will automatically be rotated by the help of gear mate. This relative motion is because of gear mate only. If I reverse the gear, the second gear will also move in reverse direction. So this was gear mate for you. So this was session 17 in which we have seen mechanical mates that were screw mate and gear mate. Please do like, share and subscribe. And for more videos related to SolidWorks, we have provided complete playlist in our playlist option. So you can go for sketcher, part modeling, assemblies. Each and every module is covered in playlist. So please go through the playlist and you will get all the options related to SolidWorks there. Till then, thank you.